The amount of data collected in science has dramatically increased with advances in computational simulations, experiments, and observations. Examining these massive amounts of data can often be simplified using tensor networks, a type of artificial intelligence that finds patterns of scientific structure and meaning in large, complex datasets.
SmartTensors is a groundbreaking, unsupervised machine learning tool based on non-negative tensor factorization, capable of extracting easy-to-explain latent features and performing analysis of large dynamic networks. Tensor networks factorize extremely high-dimensional data, representing it as chains of three-dimensional cubes.
SmartTensors is a unique platform that can determine the number of the hidden signature and patterns in a large dataset. It is a scalable platform that can work with extremely large, sparse, and dense datasets. Extracting the important hidden features from the data helps create a simplified structure that represents, compress, and interpret the entire dataset.
SmartTensors uniquely estimates latent dimensions and latent signatures in large datasets, which can be terabytes or more in size, using CPUs, GPUs, and tensor processing units. SmartTensors is written in Julia, Python, and C++, and in addition to laptops and desktops, SmartTensors can be executed on existing supercomputers and on cloud platforms such as Google Cloud.
SmartTensors has many practical applications that can help improve our quality of life, including medicine, chemistry, and agriculture, as well as aid in the warning of natural disasters. SmartTensors was applied to the NASA Deepwater Impact Ensemble dataset, a 3D set of computer simulations of asteroids that enter the Earth's atmosphere. A large asteroid impact in the ocean could generate a tsunami that has the potential to devastate populated coastlines. NASA aims to know the smallest asteroid that could generate a significant tsunami and reach distant shores. Using SmartTensors to select a few essential frames that summarize the important stages of the simulation, it is clear that it produces the best visual and strongest compression of the data.
The extracted subset of latent frames can be used to extract and understand the important physical-chemical phases of the simulated explosion, corresponding to various mechanisms encoded into the chemical content, size, and shape of the asteroids.
Climate scientists often need to comb through decades of climate data to be able to pinpoint causes of climate disasters, like the 2003 European heat wave. This heat wave led to record temperatures across the continent and tens of thousands of deaths. This simulation shows the spatial and temporal dynamics in climate conditions throughout Europe over decades. Understanding the mechanisms that cause heat waves is extremely challenging. SmartTensors analyze diverse datasets of atmospheric processes, including air temperature, air pressure, snowfall, rainfall, evaporation, and wind velocity.
Our preliminary analysis demonstrated there is no one single process that can be related to the heat wave. Rather, it can be traced to a series of processing events that reoccur with different frequencies over the years.
SmartTensors' unsupervised AI platform can quickly and efficiently sift through millions and millions of bytes of data to find hidden features and signatures that matter, with significant applications to big data problems in healthcare, national security, and many other fields. The future of big data is now simpler with SmartTensors.